Hi, for this video we're going to solve a system of three equations. This particular system is a lot more difficult than the other two that I have done, only because of the fact that nothing automatically cancels out. Like if I look at my x's, nothing automatically cancels out. If I look at my y's, if I look at my z's. There are several options that you can do. We could try to eliminate x's, or z's would be the ones that I would go with, only because they already have some opposite signs. I'm going to choose to eliminate z, so this is the column that I'm going to choose to eliminate, mainly because with this I could get these two to eliminate by just changing the sign of one of the first two equations, and then adding them together and my z's would cancel out. And I can get away with just multiplying either the first one or the middle one by 3 to get it to eliminate with this one down here. Like I said, you could eliminate the x's, you could eliminate y's if you wanted to, but the y's is going to be the most work because of the fact that I can't multiply 4 by anything to get 5 or 6. So I would have to multiply both equations by something to get them to cancel out. We don't have any opposite signs. So it's going to be more work, and you have to for sure multiply by negatives. So what I decided to do is I first decided to do equation 1 minus equation 2. So basically when I say equation 1 and equation 2, I'm talking about this equation, the first equation, and the second equation here in the order that they're written. So I'm going to keep equation 1 exactly the same. I'm not going to change this one. So I'm going to have negative x plus 4y plus 2z equals 1. The goal of a system of three equation is to first eliminate one of your variables to get down to where you have a system of two equations with two variables. And then we're going to use elimination again to get down to where we have one variable. So this is a lengthy process. For the second one, what we're going to do is we're going to take, and I'm going to multiply this by negative 1. And the reason I'm multiplying by negative 1 is because that's the same thing as subtracting. It changes all the signs, which will make this a negative 2z, so my z's would cancel out. Because remember, we're trying to get the z's to cancel out. So when I multiply this row by negative 1, I end up with positive 3x minus 5y minus 2z equals negative 12. And some of you are capable of doing this in your head. I'm showing out every single step. There are steps that I skip all the time, but it wouldn't help you if I skipped all of them and you didn't know where I was getting things from. So when we add these two equations together, this ends up canceling out, and we're left with 2x minus y equals negative 11. So there's our first equation that only has two variables in it. We now need another equation with just two variables in it. So what I'm going to do is I chose to do 3 times equation 1 and then add that, because 3 times 2 would give me positive 6, and the opposite of positive 6 is negative 6. So I'm going to add equation 3 and 3 times equation 1. I could have also done the same thing with equation 2. I could have picked to multiply this equation by 2. The second equation by 3 also, because that would also get my z's to cancel out. So there's a lot of different ways of doing this. Instead of doing this one, we could have multiplied this one by 3 and this one by 3, and then added the first and the third and the second and the third. So there's a lot of different ways of doing this. It's not just one exact method. You just kind of have to look at what you're given and go from there. So what I'm going to do is I'm going to take and I'm going to multiply this top equation by 3. So 3 times negative 1 would give me negative 3x. I'm going to multiply the second one by 3 also, so I would get 12y. As long as I multiply everything, it stays balanced. It's just an equivalent expression. If I only changed the z, that would be a problem. So you have to make sure that you change everything. And then remember, we're going to add that to equation 3. So equation 3, I'm going to just keep the same. And now when I add these two equations together, we can see that 6z cancels out. And so we're left with x plus 18y equals 13. So now we have our two equations, 2x minus y equals negative 11 and x plus 18y equals 13. And you always want to check your math because there is so much work in here. You do want to go back over and look and verify that you haven't made a mistake anywhere, that you checked all your signs, that you really multiplied everything by the 3 that you were going for. So now what we're going to do is we're going to eliminate this. So I'm going to use these two equations. And we're going to eliminate again. So what we want to do is we want to get this down to where we only have one variable. So we're going to eliminate one of our variables. It doesn't matter which one you choose to do. You can either multiply the top equation by 18 to get our y's to cancel, or we can multiply the bottom equation by negative 2 to get my x's to cancel. I'm going to choose the second one just because multiplying by negative 2 is smaller than multiplying by 18. So I'm going to keep the top equation the same, 2x minus y equals negative 11. And I'm going to multiply the second equation by negative 2. So that gives me negative 2x minus 36y equals negative 26. And then we're going to add these two equations together. So when we add these two together, my x's cancel, and I'm left with negative 37y equals negative 37. So if I divide both sides by negative 37, that gives me y equals 1. So we have our first solution, and I know a lot of you get to this point, you're like, oh, I've got an answer, I'm done. Remember, we're looking for x, y, and z, so we're not done. Even though we have an answer, we just found our first of our 3 variables. So now what we're going to do is we're going to take this y equals 1 and plug it back into one of these two systems. So with this, I'm going to choose to use this equation only because x is already by itself. So I'm going to just take and I'm going to plug y in for, or 1 in for y. So I would take x plus 18 times 1 equals 13. So we really have x plus 18 equals 13, and we have a very simple equation to solve here. So we end up with, if I subtract the 18 from both sides, x equals negative 5. So now we have 2 of our 3 answers. So what we have to do is go back to any one of our original equations. It does not matter. Remember that we are looking for, we have x and y, so we're looking for z. So you probably want to pick the z that's the easiest. I'm going to choose the first equation. Like I said, it doesn't matter which one you pick. I'm going to pick this one here. And I'm going to plug in both x and y that I found. So if I do that, if I take my original equation, the negative x plus 4y plus 2z equals 1, and I'm going to replace in there the negative 5 for x, and I'm going to replace the y with 1. And I always put a line through my z just so it doesn't get mixed up with a 2. I know a lot of times that happens. So with this, we end up with 5 plus 4 plus 2z equals 1. So we have 9 plus 2z equals 1, and a lot of these steps could be skipped here, especially since this is taking up so much room. So we end up with 2z equals negative 8, so z ends up being negative 4. So now we have our 3 answers. Depending upon the course that you're in, some require you to write it as an ordered triple. So we would just write x first, and then y, and then z. And so this would be our ordered triple. That would be our solution. It's always a good idea to check. It's always a good idea to go back and plug them in to make sure that you get the right answer. So just to kind of show you down here, when I do check this, that it does work. I have it written down on a piece of paper, so it's kind of hard for me to show you everything. But for the first equation, I have the negative x plus 4y plus 2z equals 1. So when I go back and I plug in the negative 5, a negative 5 would give me a positive 5. A 4 times 1 would give me 4, and 2 times negative 4 would give me negative 8, and we want to know, does that equal 1? And so I end up with 9 minus 8 equals 1, so that does work. For the second equation, the negative 3x plus 5y plus 2z equals 12. If we take and plug it into there, for x, remember we're replacing it with a -5, so I would do -3 times -5, which is +15. I would take the 5 times the 1, which would give me +5. And I would take the 2 times the -4, which gives me -8. And so if I add this together, 15 plus 5 is 20, and 20 minus 8 does give me 12, so we can see that that one works as well. And then just the very last equation, we have 4x plus 6y minus 6z, and we're asking ourselves, does that give me 10? So with the 4x times so 4 times -5 gives me -20, plus 6, and then -6 times -4 gives me a +24. And we want to know, does this equal 10? I would start here and go 24 plus 6 gives me 30, and 30 minus 20 does give me 10. So we can see we have verified that those answers do work in all three equations, because it can't work in just two of them. I know that this is a lot of work. This is one of those things where a lot of times I show this to students and they just think automatically, I can't do this. But the more times you do this, the more practice you get with this, the easier it gets. It is something that you really do want to check your answer, because if you don't check your answer, there's a lot of places to make mistakes. So if you made a sign error somewhere, so just be very, very, very diligent about looking at your signs and making sure that you have all of them correct. Make sure that when you distribute something that you distribute it to everything. And just go back through and check at the end. I know it takes extra work, but it's worth it because you know you got the right answer. As always, thanks for watching. If you have any questions or need other topics to be covered, please let me know.